Hello, dear students. In this lesson, we are gonna learn about Vsepr theory, Vsepr theory. And in order to understand this theory, first of all, we need to check one thing. As we already did in a lesson about the Lewis structures, we did the Water-Lewis formulas, as you can see from here. But if we check the 3D of the water molecule, we are gonna see that in 3D the shape is completely different. So Vsepr theory explains why we have different shapes and why each molecule have their own shapes. First of all, let's see what is in the name, a valence shell electron pair repulsion. So basically what's happening in here, the valence shell electrons, they repel each other. In order to understand valence shell electron pair repulsion, we have to first of all know one crucial point, which is called electron domain. Just remember that electron domain includes the electron locations. So where are the electrons moving? Okay, so it can be occupied non-bonding, it can be single, double, triple bonding, etc. So all of them are called electron domains. So let's see a few examples in here. Let's count down the electron domain numbers. For example, in ammonia molecule, we have to check for electron domain, always take the central atom. The central atom is an atom that is in the center. So as you can see, we have one single bond, one domain, two domain, three domain, and four domain. Remember, the non-bonding electrons are also one domain. So if we have four electrons. By the way, whenever we have four electron domains, it's called a tetrahedral electron domain. Remember, tetra means four. So let's check this example. The central atom is carbon, and we see we have uh, one domain in here. Remember again, double bonding is also one domain. And another domain in here. Why it's one domain? Because we have four electrons, but these four electrons are in this location, in one location. So two domains, it has two domains, and it doesn't have any non-bonding electrons. So this is called linear. Whenever we have two electron domains, it's called linear. Let's check this one. The central oxygen is this one, and we have non-bonding electrons. So what will happen? We have one domain, two domain, and three domain. Whenever we have three domains, it's called trigonal electron domain. Okay. Please don't forget them. Let's check this one. This is the example I have added in here. So we have this element is central element, and it has one, two, three, four domains. Four domain means tetrahedral electron domain. Electron domain. Okay, so let's see. One more important factor in here is that remember that in terms of the repulsive forces, non-bonding pairs are much more stronger than the multiple bonds. What do I mean by multiple, double, or triple bonds? They are much more stronger in terms of the repulsion than single bonds. So let's do this example. Let's check the example of N. Uh, H, 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 and we have, if we draw the Lewis structure, we are gonna see we have two non-bonding, one non-bonding pair in here. Remember the octet rule? And one line means two electrons. So if we check in here, in terms of the repulsive forces, non-bonding is much more stronger than the others. Yes, so we have non-bonding pair in here. We have non-bonding pair in here. So what it will do, it will repel this hydrogen. Also it will repel this hydrogen. So then this hydrogen will be forced downward. So let's see the final version. So it's gonna be hydrogen, it's gonna be hydrogen, it's gonna be hydrogen. So why it happened? Because of the valence electron shells. Remember the name? Valence shell electron pair repulsion. So these pair of non-bonding electrons, because they are much more free, they have strong repulsion forces, strength, so they will repel these hydrogens, so the angle between these hydrogen will be much lesser. So this is the molecular shape of 3D shape of ammonia molecule. Also, we can see it in here too. Let me quickly show you ammonia. I believe we cannot see it in here, so let's see. Yes, as you can see, ammonia molecule in here. You see, the blue one is ammonia, and you see hydrogens are downward below this ammonia molecule. Also, just remember that we have more electronegativities in nitrogen, so these ones are sigma negative, the downward are sigma positive. This is also polar molecule because one ends are positive and another ends is negatives.